recording. So yeah, you guys have been busy making your own automata out of paper, mechanical moving machines. This is one of the books that I pulled some of these machines from. It's actually called karakuri, which is I think it's the Japanese word for little moving machines. It has a couple different meanings. Anyway, karakuri, automata, for this class, they're interchangeable. Your assignment in class was to build one of these things, one of these paper models, so we can see some of these common mechanisms work. If you don't finish in class, build them over the weekend and bring them with you on Wednesday. Now, the other requirement, the other part of the assignment for Wednesday is to use Solidworks to build a working assembly of, I guess, representing one of these paper models that you've made today. You don't have to build the one you built in class. You could build someone else's if it's easier for you or more interesting to you. I have a whole book of other ones too, so before you leave today, if you want to take a look at some of the other mechanisms and automata that you could build, just come up and grab one. For today's demo, and it quit for me. So we're going to be in Solidworks, and I'm not going to talk so much about how to build each of the components. I think, again, with a semester and some change under your belt, building basic components, this should not be the hard part of the assignment. I'm going to leave that to you guys. While you guys were busy building your paper stuff, I actually started building two really basic automata mechanisms into my box model that was due today for you guys. I do want you guys to use your box model as like the base geometry for like where your mechanism is going to fit. And really quick, this is all in a part file, so none of this stuff moves just yet. We're going to go over the process that I would go through to import all of these individual parts, or export them as individual parts, bring them into an assembly, mate everything together so that it actually works and represents these two mechanisms. You only have to do one mechanism minimum, but feel free to do as many as are in your little paper model. As it goes with most of these things, there's a drive shaft. In this case, it's this red piece with a crank on one end. So this is going to turn. And the two mechanisms that I have in this demonstration are a cam and cam follower. So the cam in this case is just an oval cam. And if you can't imagine what it looks like when this shaft turns and the cam turns and what this cam follower's motion might be, we'll see pretty soon here in SolidWorks. The other mechanism we have is I guess you could describe it as like a crank. It's like an offset of our drive shaft, and then we have a member that's actually tied to one end. Okay? You probably could find an example of this in your paper models in front of you. A lot of you guys are doing cams and cranks. There are a couple other types of mechanisms that aren't in this demo, but that you're more than capable of building. Things like gears and like rack and pinion stuff. There's a lot of other really cool things out there. So definitely try and build something that you have in front of you for this next assignment, something that you've actually built in paper to take some of the guesswork out of it. But for the later parts of this assignment, don't feel limited by just the two examples that we're building here today or that you build in the next few days for part B of lesson 2. Okay, so right now I have, like I said, a part with a bunch of different solid bodies. There are a lot of different ways that you can export bodies from a part as individual parts so that you can bring them back into an assembly. I'll show you a way that I typically use. One thing that'll make your life easier now is to go into your solid bodies folder over here and actually name these something that makes sense to you, like bottom of, well, actually we'll do like box bottom. And I'm just going to go through this and label everything box front, box rear. The reason I'm changing the name of these is that when I actually export them, they will keep the name that I gave them. Let's see, box box, I guess we could say like left side. Box. Right side. Drive shaft. Cam. Finished?
You got 2 finished guys over here.
All right, cool. Actually, I might borrow one of these to show in the video really quick.
I don't know. This is broken. This is the extension. I don't know what the point is. You think it's essentially a setup?
Actually, where is... Some of them are, I don't know, maybe I didn't... Does it not have a box? Does your instructions have instructions for a box? Weird. So no, I guess yours doesn't have one. Drive. Okay, so I've named all of my solid bodies here, and the easiest way to export these is to pick them like while holding shift, right click, and then say insert into new part. And you know what? There's another way that we can do this too. Yeah, insert into new part. That's fine. That's fine. Okay. And it's going to ask you to put it somewhere. I'm going to drop this in a folder for part B. All right. I wonder if I can do more than one at the same time. No. Okay. So I guess you do need to do this one at a time. All right, the reason we're exporting all of these parts as, or these bodies as their own separate parts is so that we can bring them back together in an assembly and add mates to make them behave the way we want. Yet another kind of tedious and annoying part of Solidworks.
Can we stop with the pen in? Yeah.
No, I think I can spare a penny.
Maybe it's.
I don't know, it's kind of new though.
I really don't lay it down anymore.
Okay, so now I'm going to start a new assembly. And this is sort of the process here. Go ahead and start an assembly with nothing in it, and you're going to start inserting components. So I'm just going to browse for my folder full of parts that I just exported. And I might start with like the bottom piece, and I can kind of, if I can place it somewhere, or I can just hit green check mark and it will kind of lock it in place as the bottom. That's what I want to do to start. So I'm going to build up this box first. And if I just hit green check mark, a part will come in exactly the same position that it was in the part file. So for parts that aren't going to move, like your box parts, that's okay. You don't have to worry about mating them together at all. They'll just kind of snap right into place. And then for, I guess we got one other part here, top. Okay, so there's my box. There are a bunch of different parts in my assembly file, and I'm going to save this really quick as my, like, I guess part B assembly. Okay. So now is where it gets a little more interesting. I'm going to start inserting some of these components that actually move. And the first one I'm going to do is the drive shaft, since it kind of drives everything else. Instead of hitting green check mark so that it drops it exactly in place and also locks it in place, I'm just going to like pick a spot somewhere out here. And you'll notice that if I click and drag it, I can move it around. Those of you who have done assemblies is not like news, and I know some of you guys already did some stuff with assemblies and mates with the Nerf project last year. All right, because we want this to eventually be able to move in a controlled way, to spin around its axis, I'm going to add a couple of mates that restrict it in just a few dimensions. So I did a concentric mate here, so that now you can see I can drag this part back and forth, but I can't move it up and down, left and right. But you'll notice it can spin around its center, which is nice. A concentric mate allows for that to happen. The next mate that I'm going to do is one that ties the center of my shaft. And I can actually do this with the like origin of this drive shaft. If I like open this model up and say the right plane, I can mate it to the right plane of any one of my box parts. And I'll just say green check mark. Okay. Now check this out. Like, it shouldn't move back and forth, but I can actually turn this crank around, which is pretty good. So that's one step. It's pretty good. And with those two mates, you should be able to constrain your drive shaft. Whatever else is on it, it's ready to go. I'm going to close these parts down because there's actually a lot of information there. I'm going to save. Okay, let's bring in another part. Let's actually bring in the crank, the other crank thing. So we have the drive shaft handle, and I'm going to bring in the, what did I call it? Drive shaft wheel. Okay, now let's mate these guys together. So same thing. It looks like the inside of this should go around the outside of that. Green check mark. I might just make these two faces coincident. And just to test, if I start dragging this thing around, yeah, it actually moves around in a circle. And it doesn't move forward, backward. Notice there's one other thing that isn't happening. So I want, when this thing spins around, the whole shaft to spin around. So I'm going to create a mate between the, like, let's say the top plane on my wheel part and the top plane on my drive shaft part as well. And we'll see if that works. Okay, let's say green check mark, get out of here. All right, can I move this? Yeah. Okay, we're getting there. Now let's just keep adding mates to all of this stuff too. So that handle is supposed to, oh, not insert component, my bad, mate. These components need to be concentric. Maybe I want like, let's move this out. I want like this to be even here. Okay. Let's try this out. If I turn the handle, everything's moving. That's good. And you save. Okay, that might take you guys a few tries to bring your parts in, add a few mates to get your drive shaft working. That's probably the first step in this process. Then everything else, just like in real life, it's based on the position of the drive shaft. Once your drive shaft is working correctly, you can start importing these other parts. Okay, so let's do the crank follower. Okay, so it's this guy, kind of looks like a key. Any ideas what types of mates I might add to this guy? Yeah, Liam. Concentric, here, somewhere on the drive shaft, right? Yeah, down here. Okay, what else probably needs to happen? What do you think, Dexter?
Can't you make the bases of the side of the key shaft with the hole?
Yeah, you could. Okay, we'll try that out. So mate these guys, and I'll say okay. Well, let's see what happens with how it is right now. All right, so I'm gonna move this around. Okay, so part of it looks like it's working right. Like that, the bottom part of this looks right, but it also looks like that the crank follower is like moving around outside our hole there. All right, there are a couple ways that we can do this part. The first one I'm gonna try is a mate between this face and where it might slide along this, this corner right here. And not parallel, I want it to be coincident. And let's just see how that works. Okay, actually that looks pretty right. Now, technically, like at some point, see how it's kind of interfering with the bottom of that hole down there? That's fine. Probably the actual right way to do this would be to actually like set up an axis in the middle of, I guess, the hole, and then also an axis in the middle of this part, and mate those two axes together. But that's kind of getting into it a little bit much. For this first exercise here, what I really want you guys to try and simulate is the motion. So that looks like it's behaving correctly to me. It is tied to like the hole, it's also tied to the drive shaft, and most importantly, you'll see that the top of that cam follower is moving in a way that is actually like opposite of the drive shaft. Pretty cool. Yeah, and just like this line that I'm using here is still, you would probably set the axis in the hole, and you would set like a I said axis, but like a mid plane in the middle of this part to slide along that axis. Again, we're at this point just trying to sort of simulate the motion. So I think because the requirement here was we have like one part that's sliding and another part that's static, we need to find a mate. In this case, a face to a line will allow that to happen. And I'm sure that you guys could find another way to make that happen too. There, like everything in SolidWorks, there are a million different types of mates. You can go crazy with this kind of stuff. All right, so the next one I want to try is the cam and cam follower. So I'm going to insert a couple other parts. We have our cam, and we have our cam follower, which in this case is literally just like a block. That's fine. It's been abstracted. All right, any ideas here on mates? Someone who isn't Dexter or Liam. What's a mate that you guys could add? Concentric what? Like, use the terms. So concentric, this thing is called a cam. That's the drive shaft. This is the cam follower. Help me out here. That's perfect. Yeah, make the drive shaft concentric with the hole in the cam. Thanks. I know. It's technical. Okay, what else? Right now, this part still moves around kind of crazy. It doesn't look like it's tied to the motion of our drive shaft. How could we tie those two together? What do you think, Tessa?
Can you make one of the planes of the cam with a plane of the drive shaft?
Yes, exactly. That's one good way to do it. So we're going to mate one of the planes on this cam with one of the planes on the drive shaft. It's probably this one. Okay, we'll pick front plane, and where is our drive shaft? We'll try front plane, sure. Okay, let's drag this around and just see what happens. Yeah, okay, it looks like it's moving. This thing still moves side to side, so give me one more mate that might keep it from moving side to side. Someone else. What do you think, Cole?
I don't even know the words to call it. Got me on this one.
Okay, Mitch?
The lock mate?
Lock mate?
Down on the left.
Um,
Bottom left.
probably one,
Never
two.
used it. It looks like it.
Yeah, it's one that I generally avoid because it can lock things in dimensions that maybe you didn't intend. I'll give you, well, all right. This one, probably want to do like a flat face to another flat face. That should keep those flat faces from like moving with respect to one another. And it's like just a coincident mate. Now, if it bothers you that like this cam is sort of off center of this hole, another type of mate that will still sort of lock it in place is a, what is this called? Just like adding a dimension, distance. So I might say like keep it 5 millimeters. Just kidding, it just didn't do it. Did it make the mate? Let's see. It did. So I'm gonna go in, you can edit mates, which is kind of cool. I'm gonna go back in here and change the distance. There's my num lock on or something, that's weird. There we go. See how it's like putting a distance of 5 millimeters between those two faces? I think that sort of centers it up a little bit more. All right, let's twist the handle. Okay, so it looks like it's spinning. And if I click it and move it, it's not moving in any way that I don't want it to move. That's again sort of like high level what you want to try and do. After you think you have a part constrained, grab it and move it around with your mouse and just make sure that either it's not moving at all or it's only moving in a way that you expect it to be able to move. All right, so last but not least, we have our cam follower. Let me save really quick. And with this one, just like the last one, we want to line this sucker up with like maybe the edge of the hole. Any ideas for other mates? All right, this one gets a little bit tricky. Now, this particular member, I'm going to also mate here to the front of our hole. I could do a distance if it bothered me that it was, you know, not in the center. Because I know that this thing will actually just move up and down as it follows the cam. That's usually how cams work in this case. They kind of ride with gravity on top of wherever that wheel is. Now, there are a couple ways that we can make this surface always follow this surface. And one is, Oh, it didn't add it for me. Sometimes you can just do a surface to surface mate. If it doesn't like that, you can do an edge. No. An edge to surface mate. Maybe, yeah. Did it add it? Hold on a sec. Yeah, that's not right. Let me delete this. And what I'm trying to avoid, there is a cam and cam follower mate option, but that can also get kind of confusing. Let's try this one more time. So that surface to this. Yeah, this is all recorded. No, I don't want that. Alright, you know what? Let's add it and just see what happens. I don't think that's what we want. No. Alright, let me get out of here. We might be able to do an edge to edge. I'm just like trying to not get into these like more advanced mechanical mates, but okay, there is a cam and cam follower option. I'll show you. I mean, we'll just do a cam and cam really quick. So the cam path is this guy, and the cam follower is that guy, and I'm just gonna say okay. That's fine. Let's see what happens here. Oh, interesting. It is following it, but it's following it on the bottom, which is great. It gets the point across. I wonder if that's something I can adjust here. Yeah, let's try that. So usually mates have an alignment setting, whether you want them to be like face to face or like parallel. They call them, what is it, like aligned and anti-aligned. Yeah, that makes sense. That's fine. Let's see if that does the trick here. Okay, now it's working. Actually, that worked a lot better. I've had like bad experiences with the cam mate in the past, and I was like, I wonder if we can get away around like not using the cam thing, but it looks like it's actually working pretty well. So, okay, that's it. And right now we have two different mechanisms, a crank and a cam, running on the same drive shaft simultaneously, and you can kind of see how one's translating this rotating motion to just up and down, and one is translating the motion to like up, down, backward, and forward. It's actually like going opposite of our drive shaft. All right, hopefully this gives you guys enough to go on. Again, once you already have your parts created, to export them from your part file as individual parts, bring them into an assembly, stitch everything together with mates. And what I'm looking for on Wednesday is you're going to submit your assembly. Remember to include it in a folder with all of your part files too. So I need the assembly, and you guys are going to actually show us this thing moving. Or maybe I'll just open it up on the computer and like try moving it, all right? Yes, there are ways to do animations like this too, and like hit play and it will just go, but we're not going to do that yet. Yeah.
Is it just like random, like we just like make whatever, or does it like eventually make sense to like